Everyone, today I'm planning to talk about how to generate a sine wave in LabVIEW and then how to loop the sine wave through the analog input and analog output, and then after that how to create an RC circuit or RC circuit or RC filter and then test that in LabVIEW. So you go open your LabVIEW, you create project. Then you're going to have blank VI finish, and then you're going to see your front panel and block diagram. So in the block diagram, if you don't see your control panel or function palette, you're going to go to view and function palette. So the first thing I'm planning to do, I'm planning to create a signal generator. So I go to express, then I go to input, simulate signal, and I'm going to drag this and bring it here. So you see the signal generator here. You can generate different type of signal. In this case, we just want to deal with sine wave. You can change the initial frequency. You can change the initial phase, offset, and also amplitude of that signal. You can add noise, and you can also modify the type of noise. You can have uniform noise, Gaussian noise, or different types of noise. You can change the amplitude of noise as you wish, but in this case I'm not going to change anything. I'm not going to add noise in this specific right at this point, but later on in your lab you're going to do that. So here you can change the sampling. You can also change some other parameters which is related to this simulating signals. So I hit OK without changing anything at this point. So then you need to go on top of your simulate signal. You're going to go on top of offset, right click, create control. So that is going to give you an option in your front panel to change the offset as you're running your program. So also I'm planning to control the frequency. So I'm going to add for frequency. I need amplitude. Again, I go top of amplitude and then create control for amplitude. You can just expand that if you wish, but in this case, so that's offset, that's frequency, and that's amplitude. And then you can also change the phase. You can right click, create control, and this is going to change the phase if you wish to change the phase. So I'm not going to change anything else at this point, and the output, which is this output, it should be connected to the scope or waveform, something that you can check the graph. So I go to my control front panel, and then I'm going to go to graphs, and I'm going to have waveform graph. So you can modify the size of this based on what you need. Then if you go back to your block diagram, you're going to see that over there. So you're going to connect your output to this waveform, which your waveform graph. So now if you run this, you're going to see how this is going to be generated. So let's say I'm going to have offset of 0, amplitude of 1, and frequency of 10 hertz, 10.1 hertz. So you see the signal that you wanted, it has been generated. But this is not going to be real time, it's not going to be in a loop. It's going to run it just once because you didn't have any loop. So now I'm going back to my block diagram, and then I need a while loop. So I find the while loop. I'm going to create a while loop, and now I'm going to have my while loop here. So in while loop, you need a stop as well. So you're going to go on top of this, create a control, and it's going to add a stop button here in your front panel. So far you generated a sine wave generator. So if you go here, you run it, you can see in real time, you can change the amplitude, for instance 2, you can change it to 3, you can change also the offset. So you see the offset of sine wave is going to be changed. So now it's around 2. If you put it 0, so the offset is 0, so the sine wave is going to be around 0. You can also change the frequency if you want, say 50, and you can also change the phase if you wish to change the phase too. Okay, so now the next thing you're going to do, we want to loop this sine wave from one of the analog output to another analog input. So in your mydaq, you're going to connect the analog output to analog input. So you see this is ground. So the ground is connected for analog output to the ground of analog input, and also negative of analog input 0 is connected to this ground. And I connected with the yellow cable or wire. And also the positive output, analog output, which is the number 0 for analog output, is connected, looped to number 0 for analog input. So I did that already in my mydaq. So what we need to do in the LabVIEW in order to make it happen, so we need to write the signal in the analog output and also read the signal from analog input. So in order to do that, I need to go to my measurement IO, and then I go to mydaq mx. So first I want to write everything. So in order to write everything, I need a write block. And also for this write block, I need to create a channel. I have to mention, or I have to specify which channel this analog output will be connected to. So I take this create channel and I'm going to take it here and put it here. So since this is for analog output, I need to make sure to click here, and then this is right now set by default for analog input, but because I want to write something, it should be on analog output, and I want to set it on voltage. So now this channel is set for analog output. Now I need to create what physical hardware for physical output channel I'm going to connect it. So I'm going to go on the left here, and I'm going to go on top of the physical channels, right click here and create control. So now I can specify which channel I'm going to use for analog output. If you go to your front panel, you see that it appeared here. So let's move it here, and I want to call it analog output channel. So if your mydaq is connected already, if you click on drop down menu, you can find which analog output you're going to be connected or specified here. So in this case, my analog output is AO0, which I'm going to specify it here. And then you need to connect your task out to your task in of your write block. And then also you need to connect your error out to your error in of this write block. Then the next thing you're going to do, you're going to find data on this, which is here in this case, and I'm going to connect the data to my sine wave output. So now, if you run this and you have an oscilloscope, you're going to see that the sine wave that you're generating is going to be sent out through your analog output. So in this case, because I wanted loop the output and input together to see it, I need to also add some read block. So I need to add read because this is related to reading for your analog input. I need to also create a channel again. So I'm going to add a physical channel here, right click, create control. So this is for analog input. I need to connect the task out to task in of this read block, and then error out to error in of this block. Okay, so now I'm going to go to my front panel, and now I'm going to see this appear here. So this one is related to analog input channel. So if your mydaq is connected again, you drop down here and you're going to have analog input 0. You can change this one. You can change this to call it simulated signal. And now I want to see what is looped through my mydaq as far as output and input. So I need to go to view, control panel, and then graph. And this time I need a waveform chart. Make sure this is waveform chart. It's not waveform graph. It's waveform chart. So I'm going to add the waveform chart. I'm going to make it size that I want. And this one is actual or physical signal or loop signal. Okay, so now if you run this, you're going to see the analog output is going to receive the signal from this signal generator, and then it's send it to the analog output, because through the cabling and through the wiring that you had it as a loop in. Then you're going to receive that signal from analog input, and you're going to see it in your scope. So let's go back to my LabVIEW, and then I'm going to run it and see if you can see the signal. Okay, so we cannot see the signal because this is not connected to anywhere at this point. So I need to connect it to, let's stop the program. So this, I didn't connect it yet. So you're going to go your read, and then you're going to connect this to your signal. So now let's go and run it again. So you see the signal is out, but the frequency is really high. So let's put the frequency of 1 Hertz. Then you're going to see 4 volt as sinusoid that's loop in and out through your mydaq. So you can change the amplitude. You can change it to 3 in real time. You can change it to 2 and to 1 volt. So let's stop this. Now let's just go to the next step, which is RC circuit, and see what we need to do for the RC circuit. So we'll stop this. The next thing you're going to do after you find out the loop input and output, you're going to create this on your breadboard. So you are going to have an R resistor and a capacitor on your breadboard. Then you're going to have all the negatives with the yellow wire. So the negative of analog input 0, it goes to AG and D. and analog input AG&D also goes here, and all the negative goes to the negative part of your capacitor. So your capacitor has a positive and negative, so all of them is going to go to your negative of your capacitor. And then your analog output of your mydaq goes as a voltage in to this side of your resistor, and the reading or measurement part is going to analog input 0 of your mydaq as shown in this figure. So in this case, before showing that in LabVIEW, the resistor which I selected is 10K, 10 kilo ohm, and then the capacitor that I selected is 22 microfarad. So if you want to calculate the cutoff frequency, the cutoff frequency is going to be 1 divided by 2 pi multiplied with RC. So R is 10 kilo, which is 10,000, multiplied with 22, multiplied with 10 to the power minus 6. So it means your cutoff frequency is 0.7, almost 0.7. So it means that the frequency is more than 0.7 hertz, you're going to have attenuation, and frequencies less than that, you are not going to have that much of attenuation as far as the amplitude of that signal. So now let's go to LabVIEW and see if that is true or not. So let's say I put the voltage amplitude on 3 and I put the frequency on 0.03. So in this case, as you know, the frequency is way below the cutoff frequency. So we should not have that much of attenuation. So if I run it, you can see that the amplitude goes on top to almost 3 volts, which was expected to have it. So there is no attenuation. But then if I increase the frequency, let's say to 0.7, which is almost the cutoff frequency, you're going to see that there is attenuation, and now the voltage, maximum voltage, is around 1.5 and minus 1.5. So it means there is attenuation. And then higher frequency, let's say you have 1 hertz in this case, you're going to see that the amplitude goes down to almost 1.2 or 1.3, and so on and so forth. So let's say 1.5, you're going to have more attenuation in this case. You may notice that the signal is not really great sinusoid. It's because of the fact that the sampling rate is not set for higher frequency. So another great thing with RC filter is the fact that when you add noises are high frequency, so it's going to get rid of noises. Let's say I'm going to have this at 0.9 hertz, which is not much of attenuation. There is still attenuation, but it's not that much. Let's say put it 0.5, that you can see it better. And then I'm going to stop this, and then I'm going to go back to my block diagram. It takes some time for this to be stopped. Okay, so now I go here and I can add noise, and I add the noise of, let's say, 0.1 volt, or you can have it 0. Let's say more, 0.2. Then I hit OK. So now I have the signal with noise. You can change the amplitude of noise here. Let's say I can find the noise amplitude. So I can create another control. So now this is for noise amplitude. I go back here. So noise amplitude is 0.2. Now you can see with this RC filter, you don't have that much of effect of noise, while in this case you see the effect of noise in simulated much more, because RC circuit was able to filter the noise a bit more. And then you can increase the noise, you can see the noise, it appears more because the magnitude of noise in this case is much more than magnitude of the signal, so it's harder to differentiate that. Okay, so let's stop this, and then I just want to show you one more thing before I end this lecture, is we want to do the loop, and then we want to see right now you see for 0.2, you see the noise, it's not affected the signal that much, even it's like the signal is attenuated, but the noise is not there that much. So now let's stop this, and then let's go back and change everything to loop back here. And then now let's run this again with the same amount of noise. You see that the noise is more affected compared with the previous signal because you don't have the filter, RC filter anymore. Okay, I'll stop here.